Okay, so we're going to dive a little bit deeper into the exponential growth equation here. At the beginning of 2006, there were 285 cell phone subscribers in a small town in rural Laos. The number of subscribers increased rapidly, though, as seen in the table below. If the pattern continues, how many subscribers would I expect there to be in 2014? So the first thing that we're going to do is analyze the growth factor. In other words, how do you get from one year to the next? How much do you multiply? That's what a factor is, something you multiply by. How much do you multiply 498 by to get 872? Well, working backwards, we use the opposite of multiplication. What do we multiply by to get this? We would do division. 872 divided by 498 will give us the growth factor. And so when I throw that into my calculator, 872 divided by 498, I get 1.7510 as my growth factor, and I can write that right in here. So I'd like you to go ahead and try that for the next growth factor. How do you get from 872, what do you multiply by to get 1,527? And then you'll write that growth factor right here. Go ahead and try that. And let me just pause this. Hopefully you got something that looked like this here. 1.7511 or 1 in 7,511 10,000ths. If we were to continue taking 2,672, divide by this, here are all the different growth factors that we would get all the way through 2013. They look pretty close. All of them are around 1.75, 1.7498, around that up to 1.75. They all are pretty close to 1.75 in here. But how do I kind of want to find an average. What's sort of the average rate each year it would do? So to find an average, I'm going to take all of those factors, add them up, and I get 12 and 2,525 10,000ths. Divide that by the 7 different factors there are. And here's what I get, 1 and 7,504 10,000ths. All right, I want to analyze this number here so that we understand a little bit about what this factor is telling us. A factor is what you're multiplying by to get to the next number. Interesting thing, if that factor was 1, that means I would basically be taking 100% of 498, multiply it by 1, I'd still end up with 498. But I'm actually getting a bigger number, so I need to multiply a number by a number bigger than 1. I'm not just taking 100% of it, I'm actually taking about 175%. This is really interesting to be able to look at this growth factor. The 1 on this side is the 100% I started with. The part on the other side of the decimal in this case here is the extra 75% or 75 and 400% that I'm going to be multiplying by to get to this next number. And the same thing each time, I'm going to multiply by that same number each time, or approximately that same number, to get the next amount of cell phone users each year. So let's get back to the question that I was trying to find. How many subscribers would I expect there to be in 2014? Well, if I use an equation here, the y is the number of users I have, so I'm trying to find that out. I'm going to equal to whatever I start off with. In this case, it was 498 users. And I know that I'm going to be multiplying it by some factor a certain number of times. Well, here's the factor that I have here. And t is the number of years that I'm going to multiply by that factor. And in this particular case, how many years did it take me to get from 2006 to 2014? Well, that's 8 years. So I need to put an 8 in for the exponent there. So here we go. I'm going to get in there. Here's my equation. Here's the answer that I get when I throw that on my calculator. So that means in 2014, I would expect to have approximately 43,866 subscribers. All right, let's try this same idea in a COVID question here. If Texas's COVID-19 cases have been growing at an average of 3.3% every day from May 4th to May 13th, this is actual data, an actual number that I calculated here, what is the growth factor? All right, remember, and this is part of an interesting thing here, back here, this was 100% plus the 75% that it grew. So if I know that the number of cases should keep its 100%, plus it's going to grow another 3.3%, what is that growth factor going to be? Well, it's going to be 1 and 33 thousandths is going to be, again, this 1.03, that's like 103% is what we're taking of the previous day, actually. All right. So if there were approximately 32,000 cases on May 4th, if this trend continued, how many total cases would we expect in Texas by the end of May, 27 days later? So here's what we do. Again, this is looking at the equation here. This is a general thing for an exponential function. We're taking what we start off with, we multiply it by some growth factor for a certain number of times. So in this case here, we have y equals to the 32,000 cases I had in May 4th, multiplying it by 1.033. And how many times do I do that? That was 27 days later, so I'm going to put a 27. In this case, the growth factor is per day, so I'm going to put the number of days as my exponent. And I end up with expecting by the end of May, Texas to have 76,888 cases.